Assalamualaikum warahmatullahi wabarakatuh and good morning. First of all, I'd like to welcome and thank you for finding time and visiting today's webinar. My name is Ahmad bin Muhammad from the Office of Assistant Vice Chancellor, Industry and Community Network, University Technical Malaysia Melaka. For your information, this webinar series under the umbrella of Knowledge Transfer Program, or we call it as KTP, is one of the methods from the Ministry of Higher Education, MOHE, to transfer knowledge from the university to the industry. The speaker of the KTP will be provided by UTM staff who have experience and expertise in their respective fields. This program will be conducted as an online webinar using a WebEx platform, and it is free of charge. For our today's topic is implementation of seal and gasket on pressure safety valve test bench in the petrochemical, oil and gas (ONG) industry, and will be delivered by Mr. Afiq Amruddin bin Panon. Please let me introduce our speaker. Mr. Muhammad Afiq Amruddin is an analytical, excellent communication and interpersonal skill mechanical engineer and academic lecturer from more than 8 years practical experience in the chemical and academician fields, specializing in engineering projects, static and rotating equipment, engineering specification and standards, pipe network analysis, piping and industrial standards. He achieved an excellent academic record by holding a Master of Mechanical Engineering. Mr. Afiq and his researcher team also developed and implemented mechanical seals such as O-ring and gasket into pressure safety valve test bench application to seal high pressure gas and liquid medium up to 200 bar. He successfully performed a pipe stress analysis using Caesar 2 software to determine the impact of static and dynamic load of pipe structure before installation work. He also developed and designed a piping layout and PNID using AutoCAD, Plan 3D, and Autodesk Navisworks to simulate process engineering. During his tenure as a mechanical engineer in the industrial sector, he led the research and development team to study insufficient water cooling supply and return demand from the cooling tower area to the process plant. He also led maintenance team to provide engineering solution and technical advice related to plant modification, equipment upgrading, and significant troubleshooting using EMIC, RCFA, and Ishikawa methods. He mainly tackled major machine breakdown problems at the site and boosted production capacity by leading the other team members to solve operational problems related to the processing system. And without further ado, I would like to invite Mr. Muhammad Afiq Amruddin to deliver his speech. Mr. Afiq, the floor is yours.
Okay, thank you for Mr. Hafiz. Okay, Assalamualaikum and morning to all audience and all the industrial player who are watching my presentation this morning. So, as I think you guys already know that this morning I would like to share a piece of knowledge about my experience in dealing with pressure relief valve and pressure test PRV test bench. So this presentation is because of the experience due to the collaborate with the one of the industrial sector that we collaborate between UTeM and one of company in Kluang that we collaborate in matching grant. Actually, we are developed one machine, we call it as a pressure safety valve or pressure relief valve test bench, which this machine is verify or test a PRV due to the for calibration purpose. So this machine required a very high pressure application and it's very dangerous if we are not designed carefully. So by this outcome, we like to share based on the experience during development, and I hope you guys can learn something from this presentation this morning. Yeah. So I tried to share the slide. So I hope you guys can see the slide clearly. If you see the slide, so please let us know. So this morning, I would like to talk about the implementation of seal and gasket on pressure safety valve test bench in petrochemical oil and gas industry. So why we said that in petrochemical oil and gas industry, because most of petrochemical and oil and gas industry use pressure safety valve. I think almost all the application of PSV or PRV is implemented or applied in petrochemical oil and gas industry. That's why we focus in petrochemical oil and gas industry. But some of industry sectors, such as like manufacturing sector, also they use PRV or PSV, but maybe in boiler or in their process production center or process center. But I think not all manufacturing process use this PSV. So we don't want to waste our time, so we proceed to the next slide. So before we start with PSV or PRV, first of all, we want to know what is hazard, and because hazard is the dangerous or something that we are very things that we want to avoid. First of all, in industry, in industrial sector, in petrochemical, in oil and gas, I think most of petrochemical oil and gas have their safety officer who take care of this hazard. So despite safety precaution, we have some equipment failures, human error, and external event that can sometimes lead to increase in process pressures beyond safe level and potentially resulting in overpressure due to a relief event. So sometimes in process, we have some phenomenon that we want to we have overpressure, such as like we have pressure vessel or tank that during the process the pressure is increased over our design pressure. That cause we want to relieve the pressure, or we call it as relief event. So during the process, if we doesn't have any control, system control or process control, it maybe can give some dangerous to the operator who operate this machine. So that's why we are very particular and aware this phenomenon or relief event. So what is a relief event actually? So relief event such as like external fire, like external fire, flow from high pressure source, uh, heat input, heat input from associated equipment, pump and compressor, ambient heat transfer and liquid expansion in pipe and surge. The easiest way to say that the relief event is we want to relieve if the process variable of process parameter is beyond our design. So why we want to relieve? Because we want to avoid any accident in our working area. So that's why we want to avoid from this happen. That's why we create or we develop a relief event. So there's a beside the relief event, because of this relief event, we want to develop a potential line of defense, such as like inherently safe design, passive control, such as like over design of process equipment, and active control, such as what to install relief system. So this is the potential line of defense before the accident happen. We want to avoid from accident happen, so we develop a layer of protection. We call it as LOPA. We call it as layer of protection. Layer of protection starting from basic process control system. We start from basic process control system. As you know, we have DCS system, we have SCADA system. We want to control the process or normal behavior. And then we have some operator intervention. If the basic process control system cannot control the parameter, so we go a little bit beyond by operator intervention, such as like process shutdown and everything. If still we cannot contain this parameter or this dangerous parameter, we have to use emergency shutdown, such as like safety instrumented system and so on. And lastly, we have relief valve. We go beyond the safety instrument system. We use relief valve or ruptured this. This we call it as active protection layer. So if the prevention is not, it cannot contain this dangerous behavior of the system or the process, we go to the mitigation. We go to the mitigation, it means that we want to avoid from something happen. So we use a passive protection layer. And lastly, the only last thing we have to do is plan emergency and response. So emergency response layer, this is the last defense. So before the accident happen. So we call it as layer of protection. I think most the industrial sector know this layer of protection, and most of the safety officer or safety supervisor officer, I think they know this layer of protection, and they are very aware of this. So this is the main idea that we want to share with you guys this morning. So what is the relief system? The relief system is a relief device such as a pressure relief valve. Sometimes they call it as pressure safety valve. Actually, they are the same thing. Pressure relief valve or pressure safety valve, they are the same thing. Maybe they use interchangeably, but actually they are meaning the same thing. So associate lines and process equipment to safely handle the material ejected. So if the material is over pressure, if the parameter inside the pressure vessel, inside the container or anything that higher than design parameter, so we have to eject the material. So we want to reduce the pressure inside it. So that's why we have to install a relief device, such as like pressure relief valve or pressure safety valve. So as you guys know, I think most of the industrial sector know that in PRV system or pressure relief valve system, we have a lot of type of PRV, but just I share to you only 3 type of valve. Maybe this current technology, I think more advanced have much more of type of PRV. So basically, we have conventional valve, pilot operated valve, and balanced below valve. I think you guys maybe already well known this type of valve, who are dealing or who are usually purchase these things. So if you see on the diagram on the right side of the slide, you can see that there's a parts or components that actually install or assemble inside the pressure safety valve or pressure relief valve. They have some cap, stem, adjusting screw, spring, bonnet, seating surface, disc, adjusting ring, body, and nozzle. So basically, if you can see that they are running through here, this flange is installed on the top of the pressure vessel or on the top of the tank. So if the tank or pressure vessel parameters such as like pressure go beyond the design pressure, so they release the pressure until and they release to the output. This is the outlet of the process. So this spring has some set pressure. I think it's based on the design pressure of the pressure vessel. So if the set pressure is if the pressure inside the tank is meet the set pressure for the spring, so the spring will lift up the disc, and it allows the material inside the tank to release and going to outlet. So this is, I think, the basic process of release system. Okay, how pressure relief valve works. So I think you guys can see that first of all, we have position A. Initially, the disc or the disc surface area, the spring force is higher than system pressure, so it will remain inside it. So the material inside the system is cannot relieve to the outside until the system pressure is overcome the spring of force. The system pressure overcome the spring of force and they try to lift up. So the spring of force is usually set by manufacturer, but I think operator can also adjust manually, but they have to inform to the manufacturer to avoid from any misunderstanding between user and manufacturer condition. So after that, if the system pressure higher than spring force, then it's fully open. It's fully open. The inlet flowing pressure will going outlet and it will release the material to the outside. They fully open and flowing. So this is position C. So from position A, initially they close and it start initially opening and then they fully open and flowing. So this one is when the pressure is beyond then spring force and then the inlet flowing pressure will release to the outside. So as I think for those who are dealing with the pressure relief valve or pressure setting valve, I think you guys can see that there's a basic terminology for pressure who are related to the pressure, such as like bread pressure, design pressure, maximum allowable working pressure, accumulation, set pressure, over pressure, living pressure, and a lot of terminology that being created for this PRV or PSV. And then this a chart. Usually, I think most of you guys already know that this is the chart for safety relief valve. And if you can see that this is the set pressure. We purchase the safety relief valve based on set pressure, and set pressure is based on the maximum allowable working pressure on the tank. If you can see that, usually if we set the set pressure such as like 97% or 97 kilopascal or bar, we only let pressure safety valve or pressure relief valve to lift up the disc until 110. So if the disc of the inside the pressure relief valve doesn't lift up until 110, so we know that this pressure safety valve is failed. If the set pressure is doesn't if the disc inside the PRV or PSV doesn't lift up during the process until 110, so we assume that this PRV or PSV is failed. So this is the, I think, the standard operation, standard calibration that the industrial sector or oil and gas use. They allow 10% from setting pressure to make sure that the PSV or PRV is okay. So if it goes beyond than 10%, it means that the setting or set pressure for pressure relief valve is deviate from the original, and deviate from the original or from manufacturer setting pressure. So the blow down, it means that if the disc is lift up and if they want to close back into the original position, so they have some time to reset the disc to the original position. It means that they want to take a time for sit inside the PRV to reset back into closed position. So we call it as blow down. So the operating pressure actually is below than certain point. So any particular level below maximum allowable working pressure. So basically the 100% is the maximum allowable working pressure, and this is the very common chart for the reference. If you want to refer to this chart, it is very easy to understand. So also you can see that this is on the left chart, this is a lift of this by percentage. First, they will close. The disc is closing. The disc is closing. It means that it's normal operation. Then if the pressure inside the tank is achieved until set pressure, so the set pressure will relieve. Will relieve until over pressure. Then until point B, they will release back to the closing. So between this set pressure and closing, we call it as blow down. So if the set pressure, if we the set pressure we give some allowable time, we call it as over pressure. If it's beyond 10%, so we call the set pressure or PRV is failure. So it needs to be calibrated. So this is the code requirement. Basically, if some company, if they are dealing with the PRV calibration of PRV, PSV, I think they already know the common standard or code requirement they want to deal with, such as like API standard 520, sizing, selection, and installation of pressure relieving device, API standard 521, APF standard 526, APF standard 527, seek tightness of pressure relief device, and ASME boiler and pressure vessel code section VIII. So pressure vessel division 1. So all this standard is related to the pressure relief valve. So this is the example of the accidental case. If you can see on the slide, the tank roof ruptured due to the high pressure when the material were transferred into the vessel, and the flame arrestor in the pressure or vacuum relief system was plugged, but the pressure control system, which would have allowed venting to another vessel, was out of service because of the lack of the maintenance, because of the lack of the awareness of monitoring. So the pressure control system during the incident happened, they failed to perform. So this is the example of the accidental. So also the effective of high pressure steam boiler ruptured. The resulting explosion damaged nearby vessel containing flammable. So the release of flammable resulted in further fires and explosion. I think 23 workers were killed and 4 were injured. So 8 million, I think 8 million estimate property damage, I think in US. So another accident that happened is because of under vacuum. This damage occurred due to the pumping out with a closed vent. So if the vessel is not designed for vacuum, it will likely be damaged if the placed under vacuum. So low pressure storage tank and rail car are particularly susceptible to damage. Not only is the equipment damaged, but the content may also be released. So if the content is not dangerous to the people outside outside the vessel, it's okay. But if the content is very dangerous, such as like ammonia and so on, maybe it will make a very disaster event, such as like Bhopal in India. So this also one of the case. This damage occurred due to the pumping out with the conservation vent covered by plastic. Actually, they covered by plastic. The venting is covered by plastic, so the material inside cannot be letting out. Cannot be let out. So that's why it's very dangerous if the vent is covered by some obstacle things such as plastic or woods. So this also is one of the events significant vacuum can result from collapsing vapor when NSD is initiated on distillation column. So this is the example if they cannot let out. So this is if the structure is not strong enough, so the vacuum will collapsing the vapors. So the example of the accidental case, I think okay, before I start the video, I would like to explain to you why we present this idea this morning. Is because we want to share with you the machine or the test bench that verify the pressure relief valve. So pressure relief valve is the very common to the industrial sector. They use a lot of this device in many areas. But what we want to show you is the example of the machine that we create or develop and collaborate with the industrial, one of the company in Kluang. We develop a machine, we call it as pressure relief valve test bench. This purpose of the machine is to verify and to make sure that the pressure relief device is in set pressure. If the PRV is failed, so this machine will detect and we will make sure and inform to the client or customer they need to calibrate or send this PRV to the manufacturer for calibration purpose. So this is one of the product, but I think this video is from German, and this is our competitor from German. They are the pioneer of this product. So I think to make you to give you some main idea how it perform. Okay, okay, from this video, this is the brand from German. We call it as mattress. Uh, this one is one of the model that they use to verify the PRV or PSV. So to make sure that PRV and PSV doesn't deviate from the original set pressure. So if the process parameter or set pressure is deviate from the original one, so this pressure valve need to be sent out to the manufacturer to make sure that they calibrate back to the original setting. So so this is the pressure relief valve test bench. I think maybe some industry sector doesn't aware the PRV need to be calibrate. Sometimes they use many long time, so doesn't aware to check their PRV, PSV during the operation. So it's very dangerous if the setting pressure is deviate from original one. So test bench, a set of equipment used for pressure relief valve. They want to calibrate the pressure relief valve to test the pressure relief valve if the pressure relief valve is failed or not. So it has two type of tests. We call it as pop test, which is we want to test the set pressure, and then we want to test the leaking test. They call it as seat tightness test. Seat tightness test is related to the API 527. I think you guys can see that from the previous slide. API 527 is related to the seat tightness test. So I will explain to you how the test is being done by the industrial player who dealing with the PRV. Okay, pop test or set pressure test is initially build up pressure to inlet until it's open. So we give the pressure, the high pressure to the inlet. Basically, they are using the supply pressure from nitrogen cylinder. From if the application is not very high pressure, we are using 200 bar. So using air, nitrogen, water, and steam process fluid as media, they will uh, push the media to the inlet until the operating pressure should be recorded and compared to its set pressure. So we call it as pop test. So if you see on the chart that I show you from the previous slide, you see that if the set pressure will let or allow the set pressure beyond the over pressure around 10%. So if this if you can see the disc inside the PRV doesn't lift up after the 10% of the set pressure, so we assume or we ensure that this PRV is failed. Is failed, it means that they need to be calibrated or need to be repaired. So this is the basic, or we call it as pop test equal to set pressure test. Pop test, it means that the sound of pop, if you listen carefully, if the pressure release from the disc, say they will produce a sound of pop, a little bit of explosion sound, but it's not very loud. We call it as pop. That's why we call it a pop test. Pop test is equal to set pressure test. So if the pop test is beyond the set pressure test, it means that this PRV is failed. And also we give some tolerance. Some of the company or some of the oil and gas company, they also use the tolerance if the set pressure of the PRV is over 5.1 kg. They give some tolerance of plus minus 3% from the set pressure. So if the pressure doesn't release beyond than plus minus 3%, so we assume that the set pressure is deviate from the original set pressure. So there is some company they use plus minus 3% or and some company they use 10%. So I hope that you guys can understand what is the pop test and or set pressure test. So this is an example of the process. First, we build up the inlet pressure by put the nitrogen media inside the inlet, and then we increase the pressure until set pressure. So if this is lift up during the set pressure, so it means that this PRV is okay. It's okay. It means that it's normal. But if the disc doesn't lift up beyond than 10% of over pressure, so it means that this PRV need to be calibrated. So this is the pop test, set pressure test. So another test that related to the PRV test bench is we call it as seat tightness test related to the API 527. Seat tightness test, we call it as leakage test between seat and disc after it has reseated. Sometimes sometimes the PRV is normal. They lift up during the set pressure is normal, but sometimes if the seat already reseated, or we call it as blowdown test, if the seat has resisted and closing, sometimes the media or the material inside the PRV still release because of the leakage, because of the disc and seat is not very properly closed. So that's why we call it as leak test. Leak test pressure we test by using 90% of set pressure. So leakage test is using the bubble count with at least 1 minute observed. Say this table is already included in API 527. So if you want to test using the seat tightness test, you basically can refer to the API 527. So they already provided this table for you for your reference. So by 1 minute, how many leakage rate are acceptable? So if the set pressure is let's say 10.3 megapascal, if the leakage rate is around 60 bubbles per minute, so it is acceptable. So if the leakage rate is beyond than 60 minutes, such as like 100 bubbles per minute, so it means that this PRV is leaking. So you need to be lapping the seat and this to make sure that they touching or close properly. So this is the basic of seat tightness test. It's very easy to read, and you can refer to the table. So this is example of the process. First, the relief valve close, they reseat back to the original position. So the material still pushing the disc, and during this time, 90% of set pressure, we will monitor how much the material release after the closing, after the reseat of the disc and seat. So if you see on the table, you can refer to the table how many bubbles per minute it already produced. So this is the you can see this is the bucket of water. So you can monitor the bubbles coming out from this tube. So you can refer to the API 527. They already provide everything. So this is the main idea still on PRV test bench application. So as you know that this PRV test bench is very high pressure application. So if you are not designing the seals very carefully, so it means that your PRV test bench will fail. Not only fail, but it will provide some dangerous effect to the operator who operate the test bench. Still are the most important factor for a test bench to be fully functional during PRV testing. So I think most test bench can be operated up to 200 bar and 600 bar. It's very high pressure application. So design pressure depending on the model. So if it's failed in proper selection of seal for high pressure test bench, it can lead to the fatal accident. It's very dangerous. So typically test bench are operated in two different mediums, such as like nitrogen gas and liquid. So usually we are using a water. So this is the seal application, seal classification. We have different categories: static seal, dynamic seal. Basically, dynamic seal is for movement, such as like a piston inside the engine. So this is dynamic seals. But for our application in PRV test bench, we are static, and the sealing is static. So we are using the sealant. Gasket usually is used for piping and so on. So in our case, we are using sealants. And for consideration in seal selection, some of consideration in selecting the type of seal include the nature of the fluid, pressure level either side of seal, the nature of any relative motion between the seal and melting components, the level of sealing required, operating temperature, life expectancy, and total cost. I think this is the consideration if you want to choose the seal selection. And if you want to choose the seal selection in PRV test, you can refer to this flow chart. Is it relative motion? In PRV test bench, no. It doesn't related to the any movement. So we use static still. So is accurate phase location essential? So if no, we use gasket. But in our case, we need very accurate position to locate the seal. In our case, for PRV Test Bench, we have to make sure that the seal or O-ring must be located very accurate. So we go to the yes. So if the temperature is more than 100, no. So we only use O-ring. So if the temperature is higher than 100 degrees Celsius, so we have to use sealant. So in PRV Test Bench, basically, we test not in high temperature. So usually it's below than 100, so we only use O-ring. So this is seal selection in PRV Test Bench or PSV Test Bench. So basically for this left side is for seal or gasket that are related to the motion, relative motion, such as like piston and so on. So maybe I would like to explain to you about the O-rings. The O-ring is a simple or versatile type of seal with a wide range of application for both static and dynamic sealing. So this is the if the participant or the audience doesn't know what is O-ring, I think guys can see that this is the example of the O-ring. Just the simple of the circle dimension. They have some section diameter. They like a ring inside it. So an O-ring is a seal, is a molded elastomagnetic ring nipped in the cavity in which the seal is located. So in the radial motion, you can see that there's some nip emerge from the O-ring diameter, very small. This one is very, they play a particular, play an important role in sealing condition. So if the nip doesn't exist, so actually they will leak. So that's why they create some sort of nip cavity inside the elastomer O-ring. So how the O-ring operation? So if you can see that this is the O-ring, this is the groove. You can see that then this one is the surface that compress between the groove and O-ring. So from 0 bar, so it doesn't affect to the O-ring. So when they increase the pressure a little bit, pressure from 0 bar, 350 bar, 65 bars, 100 bar until 200 bar, the O-ring will start to extrude. It's like to stretch, extrude. So if the position like this, so for a long time, it will damage to the O-ring. So you can see that there are some material of O-ring extrude into the gap. This one is not good. So you have to make sure that the O-ring is designed carefully so it doesn't hurt the O-ring structure. So the principle of operation for an O-ring sealing against a fluid at various pressure is illustrated below. So you can see that this operation from 0 bar until 200 bar. An elastomer ring seal required to seal material to have an interference fit with one of the mating part of the assembly. So this is the example of the O-ring operation during the high pressure application. So for O-ring classification in the test bench, you can see that they have some dynamic such as like movement, reciprocating, rotary, and oscillating. But in our case, for test bench, we use for static. So in our case, we doesn't use radial. Radial, it means that the O-ring is installed in radial position like this. This one is radial position. But in our case, we install the O-ring at face position. Face position is at the top of the surface, like the top of the O-ring. You can see that the red one. So we are using the O-ring for face application. So for static, for axial seal in test bench, so this is the position of the face seal. For O-ring, in our case for test bench, we install the O-ring at face position. And in our case, the pressure will coming from the center. So they will push the O-ring to the wall. That's why we have to make sure that the wall of the groove and the O-ring of the elastometric O-ring must be close to each other. It means that there is no gap. So because of we want to make sure that there is no leakage or leaking coming out from the center to the outside. So if the pressure is from external, let's say they coming in from the outside, so you need to make sure that the distance between the wall of the groove and the inside diameter of the elastomer O-ring must be close. So they have some different in position of the O-ring between the inner pressure and external pressure. This application is only for O-ring for face application. So this is very important. This is very important terminology in O-ring selection. So you have to make sure that if you want to choose the O-ring, this item must be checked. O-ring cross-section, stretch, squeeze, gland design, gland fill, and compression set. So this is the essential characteristic in selecting the type of O-ring include this one. So they have 6 characteristics. So large cross-section and smaller cross-section has some impact on the seals. So if you can see on the table, the effect of cross-section, for larger section, if the cross-section is larger, it will give more stable to the application, more friction, and it will give more friction. So also it require large supporting structure, better compression set, less volume swell, and so on and so on. So you guys can read in this table if you want to apply the larger section. For a smaller section, the process become less stable. It's very dangerous, but also it will provide less friction. So it means that your O-ring will can be used in longer time. So this less friction doesn't give some damage to the O-ring, but it's less stable. It means that it's easy to leak. But it also requires less space and reduced weight, but it has very poor compression set. So you can see this is the explanation if you use smaller section. So you also need to consider the gland size and amount of skis needed. And the very important one, your O-ring cross section must larger than gland height. The gland height, if you can see on the previous slide, the gland height is the A, is the A here. The distance between the base of the groove until the top of the mating face on the top. This is the gland height. So to make sure that the sealing is very proper, so the diameter or cross section of the O-ring must higher than or must larger than this gland depth or gland height. So this is the rules if you want to choose the O-ring. Squeeze prevent leakage. I will explain about squeeze. An O-ring with small cross section is less stable than larger cross section. It's very easy to leak if you use a small cross section, but it has some another advantage, such as less friction and is very light compared to the larger section O-ring. So for stretch in PRV or PRV test bench, stretch is not a crucial effect on the application, but for piston or anything that require the radial position of the O-ring, you need to make sure that you are carefully select the stretch numbers. So O-ring stretch affects seal compression by reducing cross section, reduce sealing potential. So this is the normal condition without stretch. So after you install, such as like on piston, you can see that there's some stretch deform on the O-ring. Dia punya cross section tu akan ada sedikit turun. Cross section will be reduced. Consider the cross section reduced. Why we need stretch? Because we want to make sure that the O-ring will stick to the piston or shaft. They stick. If the O-ring is loose, so it means that the O-ring will fall and doesn't seal the shaft or the piston. So to make sure that they stick to the piston, they need to be stretched. But the stretch cannot be more than 5%. Otherwise, the sealing position between the gland depth and the cross section will be reduced. So increase stretch, you will decrease cross section. It will also reduce gland depth to the retain necessary squeeze. So to calculate the amount of stretch, this is the formula. Groove diameter divided by O-ring internal diameter minus 1 multiplied with 100%. So this is the example of the calculation. This is also for stretch. And this one is very important, squeeze. Squeeze is the amount of compression between the gland depth and O-ring cross-section. As I already mentioned, that cross-section must larger than gland depth. So if the cross-section is not big enough or not large enough, so it will not give some leak effect or seal effect to the application. So squeeze is very important actually. But too much squeeze will give damage to the O-ring, but not enough squeeze will give some leakage to the application. So the material will going out from this gap. So the tendency of O-ring to retain its original shape when the cross-section is deflected, O-ring makes an excellent seal. For our case, static application for face seal, maximum squeeze for most elastomer is less than 30%. If we squeeze or compress more than 30%, we induce more stress and will create early deterioration. It means that we will frequently replace the O-ring. It's not very good because the cost is very higher to replace. So make sure that you doesn't squeeze too much, but also need give a proper squeeze amount. So to calculate by using this calculation, cooperation ratio. Minimum squeeze more than 0.2 millimeter. Just for reference, it's just for guideline. This one is for gland design for face seal. This one is very particular because if we like our case, we want to make sure that our fabricator design this groove very carefully. We have to make sure that our dimension is calculated properly. So if you can see on this X, the X is the surface finishing, 32 micron for liquid and 16 micron for vacuum and gas. So the fabricator has to surface finish this surface very, very smooth, according to the requirement by the SAE or Society Automotive Engineering. So this is the dimension of the gland detail finish RMS values. So this is the gap of the G, the length of the groove depth, and also the corners that need to be designed, approximately around 0.005 radius. So they applied SAE AS568B gland dimension and O-ring size. So to prevent O-ring extrusion, I need to remind you that to prevent from O-ring extrusion, you need to make sure that your the corner of the groove need to be fillet, need to be fillet, don't need to be sharp. Because if you create a sharp corner, it's very easy for O-ring to extrude. Extrude, it means that some of the structure or some of the material of the O-ring will going through the gap. So will it create the damage or cutting effect to the O-ring. It's not very good and it's easy for O-ring to be damaged or deteriorate. So the design pressure is more than 1,500 psi. Around 5 degrees sloping side are acceptable and easier to machine. So this I already mentioned, break sharp corners to avoid unnecessary cutting or nicking of the O-ring during operation. So kita nak elakkan daripada O-ring untuk dia extrude masuk ke dalam gap. So we have to make sure that the corner need to be fillet, no need to be sharp. So it's very just the additional of the design advice. Okay, gland fill. Berapa banyak amount of cross section of O-ring need to be filled inside the groove depth. Basically, the guideline is 75% fill. 75% daripada cross section of the o-ring need to be filled inside the groove or gland depth. Otherwise, the seal section or seal compression doesn't give any impact on the sealing process. So about 25% void space or 75% nominal fill. So the calculation is inside this, using the formula, volume o-ring divide by volume gland multiply with 100. So you will get the percentage of the gland fill inside the groove. So you need space in groove to allow for volume swell, thermal expansion, and increasing width due to the squeeze. So why we need to consider the gland fill? Because we need to make sure that there are some space for o-ring to expand due to thermal expansion. If the volume of the cross section of the o-ring is swell, or if we squeeze the o-ring, so we need to make sure that there are some space for o-ring to expand. Otherwise, if there are no space for o-ring to fill, so it will easily extrude to the gap. Dia akan, material of o-ring ni akan keluar daripada gap-gap ni. So o-ring ni akan senang rosak. So that's why we need to make sure that the groove have some space for the o-ring to be expanded. So narrow groove for sealing is for vacuum and or gas. This is the compression set. I think the compression set is to make sure that the percent of deflection by which the elastomer fails to recover after fixed time under specific squeeze and temperature. It means that if you compress or squeeze the o-ring, if you squeeze or compress the o-ring, how much time for o-ring to deflect or to going back to the original position? So it means that if the o-ring doesn't recover after the fixed time under specified squeeze, so it means that your o-ring already failed or damaged. So the guideline is 10% or 0%. It means that there is no relaxation. So it means that your o-ring is bad, and 100% is total relaxation. So it means that it will going back to the original position. So it means that the elastic, if the o-ring is deformed, we squeeze the o-ring by specific time. So if the o-ring doesn't going back to the original shape, it means that your o-ring need to be replaced. So that is the meaning of the compression set. Low compression set is desirable but depends on good balance all physical properties. So you have to make sure that compression set is for o-ring to recover the thickness. So this is the critical operating environment factors such as like the effect of pressure, the differential pressure effect on the o-ring by forcing it to the low pressure side of the gland, causing the cross section distorted. This motion block, I think you can read this one. The effect of pressure. If the pressure is too high, the o-ring is easy to be deformed and extrude into the gap. I will show you the diagram. You can see that if we doesn't install the ring for high pressure, the o-ring will going out to the gap. We call it as extrusion. We call it as extrusion. So extrusion, it means that your o-ring, some of the o-ring structure will going or will fill the gap. So it means that it's not good. It will affect the structure of the o-ring. So for high pressure application, I advise you to install the backup ring. It's very little bit expensive, but for long-term effect, will save you some cost. So zero pressure, if you see that if you have some backup ring, it will avoid your o-ring to be extrude inside the gap. So this is the different effect of the pressure, high pressure application. So this example, material hardness of 70 shore A, steel pressure of 1000 psi, diametrical clearance of 0.016 inch. You can see that by using this chart, you see that this is the fluid pressure, VS total diametrical clearance. So if your application is more than material hardness is more than 17 short A, so it's easy for O-ring to be extrude. So intersection of seal pressure and diametrical clearance line falls to the right of the material hardness curve. So increase hardness, use backup ring or reduce diametrical clearance. So to make sure that you want to avoid from extrusion, make sure that you increase the hardness by using the highest material hardness, such as like 80 short A or 19 short A, to make sure that the extrusion doesn't occur. Unless you will have to install the backup ring. If you don't want to increase the hardness, you have to use the backup ring to make sure that the O-ring doesn't extrude. This is the guideline, only the guideline for you to refer. This is also the guideline, the same such as like the last one. This is the effect of temperature. You can see that this is the typical O-ring material that used in our application. You can see that this is the variation of the temperature effect on each of the type of the material for the O-ring. So this is also the guideline for you to use. Okay, just to inform you that this presentation is based on our project that we collaborate between the UTM and industrial partner. UTM and industrial partner Legacy Selatan Sinan Berhad in Kluang from 2009 until 2020. So Legacy Selatan, their service is to serve the client by calibrating the PRV or PSB. So they request us to develop a PRV test bench for industrial usage. PRV test bench, I think we have a lot of competitor in Malaysia, but for proper design of PRV test bench, like such as like a German brand, I don't see any competitor inside the Malaysia. That's why we want to be a pioneer for PRV test bench development in Malaysia. And the objective is to produce the product with low development costs. So the funding was separated or share 50%, 50%. It means that from total grant, we divide by 2, 50% by UTM, and another 50% is invested by Legacy Selatan. So our deliverable is we want to publish the journal paper, we want to apply the patent application, and we produce prototype, which these 3 items already achieved. We already achieved. So this is the example of drawing that we already developed for fabrication activity. And this is the plate that we already designed. So this groove we design this groove according to the guideline from the SAE, the Society of Automotive Engineering. We refer to this guideline, then we create this groove to make sure that we follow the tolerance. So this is the type. This is the prototype that we already developed. You can see that the structure that we already developed in our lab, and we already deliver this machine to our partner. I think around 1 year we need to develop this machine. Just for presentation video, I think just for your entertainment. Okay, that's all for my presentation. Thank you for watching and listen to my presentation. I hope you guys enjoy, and if you have some question and answer, you can ask me for if you have another question to ask. Thank you.
Okay, thank you, Mr. Fik, for the presentation. Okay, before we go to the Q&A session, okay, can I share some slide for registration? Okay. Okay, so hopefully all the participants can scan the Q&A or click the link that I given it at the chat box for the attendance and registration form. And then we hopefully that you can give us some feedback about our session. Okay, then for for promote, you can go to our website, Pejabat Penolong dan Chancellor Jaringan Industri dan Masyarakat UTM, and also for LinkedIn Universiti Teknik Malaysia Melaka for any new news or any new program that we will provide in the FB lah. Okay, so okay, is there any question from the members of the floor? Is there any question?
Mr. Afiq, can you hear me?
Yes.
Okay, I think I have a question from me. I just want to know, is do you have any idea the effect of the vibration to the seal or the gasket? Is it gonna be take into consideration during the maintenance or the period of when we need to do the maintenance and so on? I mean, for the part itself, there is a vibration inside it, or there is some sort of vibration involved in the tank itself. So is it gonna affect the seal?
Okay. The vibration have during our test during our test for this machine. Maybe they have some vibration, but it's very small. The vibration happen if the clamping system and the PRV doesn't lock very tight or doesn't lock very properly. So if the installation during the test is not very proper, so the vibration will be high. So to make sure that this thing can be avoided, make sure before the test, before we want to do our test, make sure that the clamping system and the subject material or subject testing have to be locked very carefully. So this vibration will be reduced. About the maintenance, I think the only maintenance that we only care is only O-ring, because O-ring O-ring is very expensive sometimes, and sometimes the operator use the cheaper one. Sometimes they use from China or China brand, but this O-ring is easily to deteriorate or easily to fail because of the damage or because of the cheap material. That's why the maintenance that have to be aware is the O-ring, and also the pressure gauge. Pressure gauge also need to be calibrated. So this the only maintenance that need to be make sure that we cover or aware during the operation.
All right. Thank you.
Yeah, Mr. Abid, just one more question. What the best material right now for the O-rings that you can use?
It depend on the application. Such as if like our application, we are only dealing with water and nitrogen. So this material or medium is not very acidic or very dangerous material or erosion material that will erode the O-ring. So we only use rubber nitrile. Rubber nitrile is very one is very, I think it's, the price is reasonable, and second, it doesn't give any problem if we contact with nitrogen and water, because for testing, the medium that we usually use only nitrogen and water. So the current selection of our O-ring material is only nitrile rubber. Getah biasa tu je.
Okay, right. So any question? Or maybe one more question from me. For the backup O-ring, that we can use some dimension, the same dimension the O-ring, or maybe a bigger or a little size for the backup.
Usually the backup ring and the O-ring is maintain the dimension, but the only dimension that we need to redesign or need to be careful is the groove. Is the groove dimension. So if you want to if you are planning to install the backup ring, you have to make sure that our groove is larger than the groove that installed for without backup ring. You understand that?
Yes.
So before you planning to design the groove, you have to make sure that you want to use the O-ring with backup ring or without backup ring. So if you use backup ring, you have to make sure that the groove must be the groove dimension need to be suit with the backup ring
It means
application.
the backup ring is larger, the bigger than the O-ring.
Yes. The backup ring, because they have some backup ring, and then in the middle O-ring, and then for internal diameter they have another backup ring. So
it should be a same material or a different material.
No, the backup ring is steel. The backup ring is
Steel,
steel.
okay.
Yes. Only the softer material is the O-ring only. But the
Okay.
backup ring is steel. It's the hardest one.
That's one. Okay, right. So any indication from the member floor? So I think is that's all. Maybe thank you, Mr. Fik, for the fruitful session today. I have also have many information from the presentation. Okay, before we end of our programs, can we open all participants open the camera that we can take a photo session? Hopefully, Mr. Alif and Mr. Muhammad Zainal, can you open the camera? We take the photo session. Okay. So, okay. Okay, all right. Say cheese to the camera. 1, 2, 3. Okay, thank you. That's all. Okay, thank you for your time and for Mr. Afid. And maybe we can see you at another session. Okay, thank you. And
Thank you, Mr. Fik.
okay,
Thank you.
all right, thank you. Assalamualaikum warahmatullahi wabarakatuh. And goodbye.